Unit 3 Chemistry, Chapter 2, Part 1. So here we're looking at energy from fuels and how that energy can be released and how we can measure how much it's released. Before we do that, we need to think about what chemical energy is. So when we talk about chemical energy, what we're talking about is the total of all the energy that's in the bonds of the substance and all its kinetic energy. Kinetic energy is movement energy for the non-physicists of you. That energy comes from the fact that there's an attraction between the protons and the electrons, there's a repulsion between the protons in the nucleus, and there's a repulsion between electrons. Plus we've got movement of electrons in their orbitals, and we've got vibration of bonds and rotation around the bonds, so the whole molecule is moving. All of that added up together gives us what's called the heat content or the enthalpy of the substance. And it has a symbol which is H, capital H. Anytime a chemical reaction occurs, the chemical energy or the enthalpy changes. So either the reactants have more chemical energy than the products or they have less. This changes energy is represented by this symbol here. This triangle we call delta H. Anytime you see this triangle in chemistry, it means a change. So delta H means change in enthalpy. And it's calculated as being the enthalpy of the products minus the enthalpy of the reactants. Okay? Sometimes the reactants have got more energy than the products. Okay? And if that happens, then we are giving out energy. Okay? And our delta H value ends up as negative. We'd call that an exothermic reaction. If the opposite's true, the reactants have got less energy than the products, then it's an endothermic reaction, and delta H, this value here, is going to end up as positive. Okay? If we look at it visually, if it's an exothermic reaction, so giving out heat energy, temperature on your thermometer would go up. Your reactants have got a high enthalpy, your products have got less. Remember, energy can't be created or destroyed, so that energy has to go somewhere, and it's released as heat. Endothermic is the opposite. Your reactants have got less energy than the products, so they need to absorb energy from the surroundings. And when they absorb heat energy from the surroundings get colder. Okay. We would normally have this delta H value associated with a full balanced equation. Okay? And we'd call it a thermochemical equation. So if we look to the combustion of hydrogen gas with oxygen, because all combustion is with oxygen, to make water, that is an exothermic reaction. The delta H value is negative. Okay? So that tells us our reactants have got more energy than our products. Okay? So we are releasing 572 kilojoules of energy to the environment. And that's 572 kilojoules per mole. So per mole in this equation. So per 1 mole of oxygen, but per 2 moles of hydrogen. If we reverse that reaction, then the value of the delta H stays the same, but it now acquires a positive sign. Okay? Because basically we're going exactly the same thing, but in the reverse, and the enthalpies of those reactants and products is set. Yeah, so the difference between them is the same. What changes, by virtue of the sign changing, is whether the energy is being taken in or given out.